All right. All right, so let's go ahead and get started. So, with this pointer stuff, I'm going to go ahead and do a lot of drawing in this class. That's all I do. Okay, I just draw things. Okay, I don't do any coding. And by the way, I should tell you, that as you're coding, you may come across problems, and you may want me to go ahead and debug your code. I can't debug your code. You're going to have to debug your own code. All right, I can give you pointers, okay? And I can go ahead and just tell you about the concepts involved, but in terms of just stepping through your code and trying to find out what the problem is, you're going to have to go ahead and do it on your own. Now, there's one issue that we actually have in this class, and that is, for the past few semesters, we've actually had some really good tutors, and they've been extremely helpful. Unfortunately, we don't have any tutors this semester. There's no one. So I'm going to go ahead and try to see if I can get the person who was tutoring last semester to come by. And if he does, he's going to go ahead and charge quite a bit of money. I think he's going to go ahead and charge like $25, $30 an hour. Okay? And that's a lot of money. I will try to go ahead and find other people from my previous semester. I think that I may not be too successful, but I will make an attempt. Okay? But at this point, it's basically just you guys, and since I can't help you too much, just you guys. Isn't that great? Okay, good. Let's get started then. All right. Let's go ahead and take a look at that. Okay, int A. The way that I like to go ahead, and let's just go ahead and assign it to 5. The way that I like to go ahead and represent that is to go ahead and say that we have a box, and this box is comprised of 2 parts. There is the actual content, and then there is the address. And so in the content, I'm going to go ahead and put the 5. And then in the address, I'm just going to go ahead and make up some address. Now, of course, the address is usually in this hex, format. I'm just going to go ahead and put in this raw number, okay? And we don't have a choice in the matter. How you doing?
Just wondering, so are your YouTube videos not going to have any of your voice because you don't have a microphone? Or?
No, it has voice.
Oh, you just picking up your...
Yeah, I checked it.
It has voice?
All right.
Yeah?
All right, thank you.
Yeah, because that would be worthless, no voice, right? All right, okay. All right, so let's say that this is sitting in some address, and let's just go ahead and say it's address 100, okay? And really what is going on is, in here, we're storing an int, and whenever I go ahead and say A, okay, that actually gets me access to the content. Now, if I was to go ahead and use this symbol, there it is. Okay, and that's the ampersand. A, that would actually go ahead and give me the address. Yes? So that's pretty simple. So if you remember from your C days, if you go ahead and do cout A, that gives you 5. If you go ahead and do cout ampersand A, that gives you 100. Yes? And you can modify the content. So you can say A equals to 10, A equals to 50. But you cannot go ahead and modify the address. Now, we know that that's not the only kind of variable that you have. You have other variables as well. So you can have something like this as well. Int asterisk b. Okay? Now, let's go ahead and now that's a variable just like any other variable. So let's go ahead and draw that variable. And this variable, like any other variable, it's got a content and it's got an address. Now, the address, we have no choice in the matter. So let's just go ahead and come up with some address. I'll go ahead and put in 200. Now, what about the content? What can you put in there? Well, let's just go back to A here for a moment. A says that you can store an int. But B, it says, why don't you go ahead and store the address of an int? That's what that means. So in here, I can go ahead and put in the address of an int. I cannot put in an int, but the address. Now let's see. Do we have an address of an int? Well, here is the int, and there is the address of the int. Yes? So what I could do is I could actually go ahead and take this 100, which is the address of the int, and I can put it into the content area of that box. Because remember, every single variable has a content and an address. We can't mess with the address, and we need to make sure that we put in the content that it says it can store. And in here it says it can store the address of an int. And we have the address of an int right there. So what I could do is I could actually go ahead and say ampersand A, which means that I could actually go ahead and put in that 100. Yes? So far? Yeah.
What if you leave it uninitialized?
Well, we know that with C, if you have variables that are not given a value, they'll contain garbage. Yeah. Now, let's go ahead and take a look at this. At this point, once again, I could actually go now, so this is B, and this is ampersand B. So in every single scenario, you have the variable itself giving you the content, and then you can have the address. So what that means is I can go ahead and do a cout B. And that gives me what? That gives me B. And that's that 100. If I say cout ampersand B, what does that give me? 200. But there's one more thing that's going on here. You see, apparently we have a link right here between these two, don't we? So then what I could also go ahead and do is cout B, and then I could go ahead and put that asterisk. And now that becomes what is referred to as a dereferencing operator. Now let's go ahead and find out how we decipher this. Now when I look at something like this, the way that I go ahead and read this is I say, okay, let me find out what is in B. What is in B? 100. Then when I come across this, that says, give me the contents of whatever's sitting in that location. Well, what are the contents that are sitting in location 100? 5. And so that gives me the 5. Are you with me on that? So look at the way that I phrase that. Give me the contents of what is sitting in that address. Now, let's go ahead and continue on with this. Now we can have another variable here. Int asterisk C equals to. Let's not worry about the contents yet. But this is a variable like any other variable. And we know like any other variable, we have a content and we have an address. And the address, we have no choice in the matter. It's going to be just given to us, okay? So let's just say it is address 300. Now, we know that whenever we say C, it's going to be right there. Whenever we say ampersand C, it's going to go ahead and give us that address. Now, but this piece right here is what we care about. This is actually telling us what we can store in the content area. And it says what you can store is the address of an int. Now, when I say the address of an int, that sounds a little confusing, okay? Or in this one, when I say the address of an int, what does that even mean, okay? With this drawing that you're looking at, you can think of each of those asterisks as like a jump, okay? It's a jump that you make to get access to that final int. So if you're over here and you want to go ahead and get access to an int, you need to go ahead and jump how many times? 1, 2. And hence you have 2 of those asterisks. If you're sitting on B, you need to go ahead and make 1 jump to get access to that int. If you're on A, you don't need to make any jumps. You already have access to the int. And so in this way, whether it's 2 pointers, 2 asterisks, 3 asterisks, 4 asterisks, it doesn't make any difference. Now, at this point, so then this is telling me that I need to go ahead and store a double jump address. And that's the only thing I can actually store in there. And that double jump address, it needs to finally land me on an int. Well, where can I find a double jump address? There it is, 200. That is, if I go ahead and put that 200 in there, look at that. I can go from 200 right here. I can make a jump, land right there. I can go ahead and make another jump and land right there. Those are two jumps that I make and I land on an int. Let's go ahead and find out all the various possibilities that are available to us. C out, C. Well, what does that give me? 200. C out, ampersand, C. What does that give me? 300. Now, at this point, I do a C out, and I do asterisk C. Okay? Well, let's go ahead and find out. C by itself gives me 200. That asterisk says, tell me what are the contents of what is sitting in address 200. So I go to address 200, and its content is 100. Well, what happens when I go ahead and do asterisk, asterisk C? This gives me 200. That says, why don't you do a jump? Give me the contents of what is sitting in location 200. That's 100. This one says, why don't you tell me the contents of what is sitting in location 100? And that's 5. Yes? Now, we could actually go ahead and play another kind of game with this. I could actually go ahead and do something like this. C out, C, ampersand, asterisk, asterisk, ampersand. And then I'll go ahead and put another asterisk right there. Okay? Based on what we know, we should be able to go ahead and find out what that means. Well, let's find out. If I go ahead and do a C, that gives me what? 200. Then, this 200, where is it actually stored at? 300. Then this one says, why don't you give me the contents of what is sitting in location 300? This one says, well, tell me the contents of what is sitting in location 200. This 100 that I'm looking at, where is it stored at? And what is sitting in location 200? Do you see how this works? It's all just that game that we're playing. Okay? The ampersand will always go ahead and land you on the address. And this asterisk is saying, give me the contents of what is sitting in that location. That's all that it does. Now, there is one more thing that I need to go ahead and share with you about this. Jeez. All right, let's go ahead and try this again. Okay. Now, if I go ahead and do int a, and a equals to 5, that would be the same thing as this, wouldn't it? That is, I can declare and then assign.
Yeah.
It's all the same thing, isn't it? Now, by the same token, I could actually go ahead and do int asterisk b, which is declaring the variable, saying b is able to go ahead and store the address of an int. And then I can go ahead and do a b equals to ampersand a. That would be the exact same thing. You see, in every single one of these scenarios, what I'm trying to do is I'm trying to put something in the content area. The one mistake that folks make is that when they look at something like this, they think that in int asterisk b equals to ampersand a, you're declaring, so here it is, you're declaring. But then they make the mistake of thinking that asterisk b is being assigned to ampersand a. No. What is going on is when you look at this, you declare the variable, which is what we have done here, and now at this point you want to go ahead and put something inside the variable. Well, the content area of the variable is just plain b, and that's what we're doing. B equals to ampersand a. So this right here would be similar to what we're looking at right there. Or, in this case, it's int asterisk asterisk c, and I could actually go ahead and say c equals to ampersand b. So what is going on is there is the declaration, but in terms of the actual assignment, that's the assignment. That's the assignment. Yes? So make sure that when you're actually assigning these things, okay, that you are mindful of really what it is that you're assigning. Because if you're assigning asterisk b, look at that. Asterisk b, that's landing you right here. You don't want to... That's right. Okay? Asterisk b is going to go ahead and land you right there, and you don't want to assign a value there. You want to go ahead and put something in here. Okay? So make sure you know exactly where these boxes are. Now, the other thing that we need to keep in mind is that in here, when you have this int, you're going to go ahead and store an int. In here, when you say, I want to go ahead and store the address of an int, make sure you store the address of an int and not the address of a double or the address of a float. That's not going to work. Also, if you're storing a single jump address, you go ahead and give it a single jump address, not a double jump address, because that's not going to work. This will all go ahead and give you compilation problems. Or in here, when it says give me 2 jump address to get access to an int, give it a 2 jump address. Don't give it a 1 jump address. So what this means is that when you have an int asterisk asterisk c, you cannot go ahead and assign it to ampersand a. That is, I cannot go ahead and store in that location 100. Because if I do, then in order for me to get access to an int, how many jumps do I make? Just 1. But then this thing says you need to make 2 jumps to get access to an int. So everything has to be compatible, both the number of jumps and the actual destination and what it is that you want to go ahead and get access to. So let me go ahead and pause here for a moment and see if you have any questions. Yeah.
You reference B, you get A or 5?
So this piece right here, when you do an asterisk B, okay, so that B gets us the 100, and this one says, tell me what's sitting in location 100, which is 5, which happens to be the exact same thing that A contains. So both A and asterisk B contain the same information.
But can you reassign asterisk B to a new thing?
So,
And where change A?
So what you could do is the following. You could actually go ahead, given this assignment that we have, if I was to go ahead and do asterisk b equals to 15, well, asterisk b is going to go ahead and land me here on that box. And so then I can go ahead and make that 15. Now, maybe the question is, can I go ahead and take this 100 and have it point to some other int? And the answer is yes. So if you go ahead and declare another int of some sort, so let's say if you have int d, well, there it is. D, it's got its own address, and you can put whatever you want. And instead of actually saying that, you know what, this B is going to contain the address of A, which is 100, you could actually instead say, you know what, I want to go ahead and put the address of D in there instead. So then this means that instead of 100, you would have 400. And so then what that means is that when you go ahead and do an asterisk B, it says, give me the contents of what's sitting in location 400, which is right there. So you could actually go ahead and point to whatever you want. Does that answer your question?
Yeah.
Okay, good. Yes?
So basically, when you did asterisk B equals 15 down there, if you were to later in your code try to see out A, you would get 15.
Yes, because it's all looking at the same thing. Yeah. So, all this asterisk stuff is a way to actually go ahead and dereference, which is get access to some other stuff. Now, keep in mind that all of this stuff right here that we're looking at, the B and the C, it's useless if there are no ints. There has to be an int that we ultimately want to go ahead and get access to. It's kind of like, when somebody gets married. Who's married here? Okay. All right. Any ladies here married? Okay. Well, if you're a woman and you're getting married, okay, at the end of the day, when you get married, okay, when you sign that contract, what do you want? You want that diamond ring. So what happens is this is the diamond ring. At the end of the day, all of this stuff is for that. Yeah? So if you don't actually have that valuable stuff, it means nothing. All this pointer stuff is at the end of the day to get access to a char, to get access to a double, to get access to a float, to get access to an int, to get access to these primitive data types that actually hold real values that give us something to go and do something with. The rest of all these addresses, they mean nothing to us if we don't have that int or that float.
So, didn't you say that you can only do this with an int, not a float or a double?
Well, right over here, these are ints. But if you actually go ahead and make it a float, then you can go ahead and store the address of a float. So everything has to be compatible. Correct. Yeah.
So if C had been set to A, it
No.
would, with what you have up on board,
You
right
can't.
there,
It'll give you a compilation error.
would it try and find what's in location 15 then?
Well, once again,
Reference?
if you go ahead and encode, instead of putting in, so if you go ahead and do something like this, let me just get rid of this stuff right here. If let's say you go ahead and come up with the following declaration, int asterisk asterisk C equals to ampersand A. Yes? What that means is that you have a box, and this is a 2-jump address to get access to an int. And let's just say that that's 300. And you're putting in the 100. Yes? Now the question is, when you have that 100, will it take 2 jumps to get access to an int? No.
Try to take the set.
So it will not take 2 jumps, right? It just takes 1 jump. Now, when you go ahead and attempt to go ahead and make that assignment, you will not even be able to compile your code. C will give you an error message. So you will not get beyond the syntax. Yeah. So, C is not good with really any kind of error checking. This is the one thing that it does check. Thank God. Yeah.
Are we going to do C for the whole semester?
So that's a good question. This class, we're going to go ahead and deal with these algorithms, and they have nothing to do with object-oriented programming. Okay? The algorithms pertain to something else. Now, being that there are those of you who may not be really very good at object-oriented programming, I think it's best to just stay away from it. Let's just go ahead and do pure plain C. Now, of course, you could use C out and C in and all that, okay? But we don't need any classes. We don't need any .h files. We just go ahead and do everything in C. Yeah? Yeah.
Can we turn in C++ file?
Well, you mean the extension of the file?
I mean, if we were to use C in and C out.
Yeah, you can go ahead and, it's going to have to be a C. When I say C++, I'm in essence saying that you are not going to go ahead and create classes, and there is no such thing as inheritance. You don't use any of those, okay? But you could actually go ahead and just write a C program, and you can incorporate a bit of C++ with like a C in and the C out. But that's not really any kind of object-oriented programming. It's just like some syntax. That's all it is. Yeah. So if you wanted to, you could actually go ahead and use, let's say, the string data type, okay? And the string data type is something that's made available to us in the C++ world, but it's not available to us in the C world. And you could do that. But my emphasis is that you will just not be using any of the class information that you've acquired in the CISP 400 class. Yeah.
Well, yeah, so with the string, this doesn't apply because it's a character array, and it's something else, so you just gotta stick to that primitive for now.
Yeah, so for right now, it's all the primitive data types. Okay, any questions? Well, let's go ahead and just continue on with this pointer stuff. Now, let's go ahead and see what happens when you're dealing with arrays. So let's just say that you have this array. Okay, so let's just say that you have an array that looks like that. Okay, so how many ints do we have? 3. Well, let's see here. Here's 1. Here's 2. Here's 3. Yes, there are 3 ints. Now we know that each one of these ints has what? A content and an address. Content address. Content address. Content address. And we also know that when you're looking at arrays, they're contiguous. That means one int is going to go ahead and be followed by another int, and they're going to be right next to each other in memory. That's just the way things are, okay? It's a contiguous memory space that is actually allotted. So this means that if this is an address 100, okay, then the next int that we're going to go ahead and be made available to is going to be, well, 4 bytes away, because each int takes 4 bytes. So that's going to be in location 104. The next int is going to be in location 108. And so this means the 1 goes here, the 2 goes here, and the 4 goes there. Yes? Now, when it comes to arrays, okay, at this point, we're looking at this A. The question is, where do I put this label A? Now, the way that I'd like to go ahead and do this is I'd like to go ahead and just come up with this kind of like root, okay, with this kind of thing that is pointing to all this stuff right here. And in here, I have the beginning address. So really, when you're thinking about A is a variable that contains the beginning address of this entire array. And if you have the beginning address, you can figure out the rest of it. How? Let's go ahead and find out. When you want to go ahead and get access to this right here, what is that? A sub what? 0? And then A sub 1? And then A sub 2? Okay? And that gives us this stuff right here. But let's go ahead and rewrite this stuff using pointer notation for a moment. Apparently we have this thing called indexes, 0, 1, 2, yes? So let's just go ahead and put this to the side here. So this is 0, this is 1, that's 2. Okay, now, what happens if I go ahead and do the following? If I say, you know what, I have A. Now, let's just say that I'm interested in grabbing a hold of that 2, okay? Well, what happens when I go ahead and do A plus 1? Well, what is 1? 1 is not just the number 1, but 1 is 1 int. Why? Because we're looking at ints. So it says, hey, wherever A is, which is 100, I want you to go ahead and move by 1 int forward. So that 1 is really equivalent to 4 bytes. So that A is 100 plus the 4, that gives you what? 104. Now, at this point, what happens if I want to go ahead and get the contents of what is sitting in location 104? Don't we have an asterisk? What does asterisk do? Give me the contents of what is sitting in some location. I've identified the location. A plus 1. So it just so happens that this is the same thing as that notation right there. Because all it is just some math. Just keep in mind that this 1 is not just the number 1, but it's that 1 int, which is equivalent to the number of bytes that it takes to go ahead and store an int. Okay, so now we understand, how these things work with regards to arrays and just normal variables. Now let's go ahead and just pass this information. Okay, let's say that we want to go ahead and pass So here we have this int a, and it equals to 5. And I want to go ahead and pass this int a, func a. Now, here on the receiving side, what do? A copy. Yes? So what is happening here is I have a variable, a, it contains a 5. And then what do? I go ahead and say, you know what? I'd like to go ahead and pass to you a 5. And then what do? This says, why don't you go ahead and just create another variable, call it a copy, and put in the 5. Yes? And so whatever changes I make to a copy inside of this function will not affect this. Yeah? Now, let's go ahead and do the following. What happens if I go ahead and store func, and then this is a call. If I go ahead and just say, I want to go ahead and send an ampersand. So let's just say this is location 100. So what does that mean? At this point, I want to go ahead and send what? That 100. What is that 100? It is the address of an int, isn't it? So, what I could do is I could say, you know, I have this, and what is coming my way is the address of an int. So I need to actually have the readiness. I need to have the kind of variable that's able to store the address of an int. Yes? You see, when I was sending an int, I was storing an int. Now I am sending in the address of an int, and so I need to go ahead and be able to store the address of an int. So, send the address of an int, catch the address of an int. Because what does this variable do? It's a variable that can hold the address of an int. And so, really what is going on is I'm sending this, and here I have a variable. It's called a address. And I'm putting in what? That 100 in there. Do you see how this is working? Yes?
So would that a address be like a 2-step jump?
Well, is that a 2-step or is that a 1-step?
That is a 1-step, but that is holding the address of another.
So let's go ahead and find out. Let's just imagine. So at this point we have a connection. Yes? So what happens if I go ahead and do a address and I go ahead and put an asterisk? Yes? Let's go ahead and see what happens. And I just say that I want to go ahead and set that equal to 50. So here I am inside of this function. Well, what is a address? 100. And then this one says, give me the contents of what is sitting in location 100. Well, where's location 100? Right there. There is the content. Let's set it equal to 50. Yeah? So the nice thing about this pointer stuff is you can move across functions, okay? And it's almost as if you have no functions. Because in essence, this is what we were doing as well when I was showing you the other example. It was just a bunch of connections, and as long as you can go ahead and do the jumps, it doesn't matter where you are. You'll land in some place and you have access to the information to change it or to read it or to do whatever you want. All right, so we're good with this so far? All right. Now, let's go ahead and do one more thing. So we have this int a equals to 5. And then I have this func a. There's that. And we know that we have this box. And in this box, we have that 5. And that is sitting in location 100. Okay. So that's a function call. Now take a look at my function call, my function header. I do func, and I do int, and I do a. Let's just call it a, because we can call it whatever we want, right? I don't actually have to go ahead and call this any. I mean, I can call it B, C, crap, whatever. Okay, it doesn't really matter, because this is just some formality in terms of what name I give it. But what I'm going to do this time is I'm going to go ahead and put the ampersand right there. Yes? Now that's kind of interesting. That syntax, let's see if we can make some sense out of it. So this is a function header. Now notice we have A, which is right there. We have ampersand A, we have that. But there is no ampersand here, that's just plain A. But we see the ampersand here. Whenever you see an ampersand in the function header, you know what that means? It means that all you have is just, let's go ahead and call this a alias. Let's go ahead and just give it that name so that we don't get confused. All it is, it says, hey, a alias. This is another name for that box. So what you do is you actually just come up with another name for that same box. It's kind of like, you know, if someone is called, let's just say if they're named William. What's another name for William?
William.
Bill, right? William, Bill. That could actually be the same person, right? Well, that's exactly what's going on. This box right here, it's A. But what if we could actually go ahead and come up with another name for that same box in this other function? A alias. So this means that I could actually go ahead and say A alias equals to 10. At this point, it directly goes in here and it changes that to 10. Or if I say cout A alias, well, that's just another name for this box. And actually, if I go ahead and do like ampersand, that's going to go ahead and give me the 100. It's just another name for that same box while you are inside of this function. Now, this is kind of interesting because we are not creating another memory space. You see, in all these other examples that I was showing you, I created a memory space here and then another one here. I created one here and I created there, whether it was just a normal variable or had that asterisk. But the minute you go ahead and introduce that ampersand into the function header, you no longer create another box. You just come up with a label that corresponds to that box that you've identified right there. Are you with me? And now, the nice thing about this way of doing this, do you notice that when I go ahead and say A alias equals to 10, I no longer have to go ahead and use any of this asterisk. There's no dereferencing. That is, I have a connection to another box without actually having to go ahead and use any of this asterisk stuff. So it simplifies your code. Because take a look at this. Here, using this notation without the ampersand, I made a connection. I put that 100, which is the address of that box right there. And then I needed to go ahead and use this asterisk notation to be able to go ahead and make a change there. That's too much. In here, because I went ahead and said that this is just another label for that same box without having created another box, I could just go ahead and use A alias, just like I would actually just use A. Any questions? Yeah.
Well, with the first one that you just showed me, you passed in the...
Where's the first one? This one?
The one upper one, yeah. So you passed in and A, right?
Ampersand A.
Yeah, that's why you're using the dereference. But in the last one...
Now,
you just
hold on.
passed in-
If I may just stop you for just a moment. I go ahead and pass in ampersand A, which is that 100, which is the address. I am not dereferencing here. Okay, so it is important to keep in mind that when you go ahead and declare a variable as such, you're not dereferencing. What this means, so this asterisk actually has meaning depending on, it's got a different meaning depending on the context. In the declaration, okay, when you actually come across that asterisk, this says B is a variable that can contain the address of an int. That's what that means. There is no dereferencing. However, once you're done with this, with the declaration, if you go ahead and say B and then asterisk equals to 5, now this is dereferencing. And that's one of the confusing things about this C programming. Because in this one context, it means one thing. In this other context, it means something else. Or in here, this ampersand means the address, but in this other context, the ampersand does not mean the address. It means you're looking at just another label for that other box. And this is, of course, the one reason why everyone gets confused with this pointer stuff. Because if you don't make that distinction, you will forever be confused about how this stuff works. Yes?
So you're saying that it's like ampersand and A is, it only references just that A when it's used in that context?
That is correct. Yes. And this one right here, in essence, is just that box. It's just another name. Kind of like, the William Bill analogy. It's all going to that same person. It's just a different name. Yeah.
So the code should just work fine, even if you don't have that ampersand in there.
If you don't have this ampersand,
Yeah.
well, the code will work fine, but let's just go back up here. Notice I don't have an ampersand right there. But if you don't have an ampersand, what do? You create a copy. You have another variable. And all you're doing is you're just copying that 5. And whatever changes you make, it only makes it to this. It has no effect on that.
That's a reference to what
So that's why, the reason why we say it's an alias, it's basically just another name for that other original variable. And any changes you make to that alias variable will affect the original. Yeah? Okay. All right, let's now take a look at this right here. Now, we understand, how this stuff is beginning to go ahead and work. What about arrays? What happens when you want to go ahead and pass an array? We said that with arrays, apparently if you have that beginning address, you can go ahead and figure out all the other addresses because they're all connected together. If you have this base one, I can go ahead and get access to this one. So, let's go ahead and now pass an array. So, func. If I want to go ahead and pass the array, what do I put in there? Which is A. That's it. But what is A? It's 100. What is that 100? It's really that 100. And what is that 100? It is the address of what? The first one. And that first one, what is in here? An int. Yes? So really what A contains is an address, and that is the address of an int. Well, guess what? If you're sending the address of an int, then you have to catch the address of an int. Yes? So then, what occurs is you go ahead and say that, you know what? I want to go ahead and catch the address of an int. And so what happens? You have a variable. And what is in this variable? 100. And this is just some other variable. So this means that now you have access to this information. And you can go ahead and get access to this array however you want. Now, you may find that when you're dealing with arrays, in the function header that you're looking at, you may come across a different syntax. So that syntax right there, which you may be used to, would be something like this. Right? You may have come across that syntax. Actually, this goes right over here. Okay? But, so the brackets will actually go ahead and appear, but I'm just saying, that these brackets, they mean nothing to us, okay? The brackets are the same thing as this thing right here, because that's really what's happening behind the scenes. You're just storing the address in this one lone variable right here. And once you have the beginning address, you can figure out the rest. Okay, so now we have all that. Now let's go ahead and just elaborate on this a little more. So if you have int A equals to 5, int asterisk B equals to ampersand A. Let's go ahead and just draw the pictures here. So here's A, 5, 100. Here's B, that's 200 and 100. Notice we have that link right there. And now, what happens if I go ahead and send in func B? If I go ahead and send func B, the function header, what does it look like? What am I sending? What is it? I'm sending what? The address of what? Which is the address of an int, right? B can hold the address of an int. That's what I'm sending. So then I need to be able to go ahead and what? Catch the address of an int. So then I can go ahead and say int asterisk, let's say B. And we can make it B copy. Why? Because right here, I'm coming up with another variable, and I'm able to go ahead and put that address 100 in there, because that's what B is. B is 100. You're sending in that 100, and it's storing it right there in B copy. Now, what happens if instead I go ahead and send func ampersand B? What am I sending? That's right. I'm sending in 200. You see, so then I need to actually have the kind of variable that's able to go and store 200. Well, what in the world is 200? 200 is an address. What's inside of it? Another address, isn't there? And keep in mind that when you're trying to figure this out, at the end you need to get access to that most valuable thing, our diamond, or in this case, that int. So basically what we're saying is that when you actually send that ampersand B, you will actually go ahead and have a variable that's going to go ahead and hold that 200. Well, if you have this variable that's holding that 200, how many jumps do you need to go ahead and make to get access to that int? Here is 1 jump, there is 2 jumps. And so hence, you have func int asterisk asterisk, let's say, I don't know, call it C, whatever. Okay? Yes?
For the function where you just called it with B, would that function do essentially the same thing if you called it with asterisk A and sorted just
Okay.
A copy?
So, he's indicating that instead of actually putting in B, which contains the 100, could I have instead gone ahead and done something like this?
And change the
Ampersand A, right?
asterisk A.
Oh, asterisk A.
Asterisk.
Now the question is, so let's go ahead and find out. Before even getting involved in that, this is our A. When I do cout, asterisk A, does it even mean anything? Well, what is A by itself? At this point, what is A? 5. And what does this thing say? Give me the contents of what is sitting in address 5. Is 5 an address? No, 5 is just an int. You can only go ahead and grab the contents of an address, not an int. You cannot grab the contents of a float, okay? The float is the contents, okay? There's nowhere else to go. There's no more jumps that you can make after this. That is our final destination.
If you do it with ampersand, would you get an actual address?
So you want to go ahead and change this instead of asterisk A to ampersand A? Right. So ampersand A, what are you passing? 100. What is that 100? It is the address of what? An int. Yes? So then you need to go ahead and catch the address of an int. So whether you send this 100 here or that 100 there, it's all the same thing. This is the address of an int. This is also the address of an int. This address of an int is sitting inside of its own variable. This address of int is sitting inside of another variable. We're holding it in the contents of some other variable. And it's important for us to go ahead and draw these boxes so that we know exactly where we are. Because you see, without the boxes, you could land like right there, and that could just mess up all of your syntax. So we need to know exactly where we are. Yes?
So will that give you an error or just give you 5 itself?
Which one?
The corner, the Ciad asterisk A.
The Ciad asterisk A?
Yeah.
This would actually go and give you a compilation error.
Error.
Yeah. Because it's just illegal. Yeah. So what do you think about this? Yeah? Okay, so hopefully this is making some sense. Now, just in case this is getting confusing, I went ahead and recorded these videos some years ago, and they're very grainy. The quality is extremely bad. My voice is even worse. Sometimes I'm eating, so it just sounds even worse than worse. And then I go through these concepts a little slower, okay? And so hopefully that should help somewhat. Yeah. But, the one thing that we want to go ahead and make sure that we understand is that, when you're dealing with functions, okay, there are times that you create variables and you store information inside of those variables. And there are times when you're actually dealing with this alias stuff, and that's because you've introduced the ampersand into the function header. And that will make all the difference in the world as to whether you create a variable or you don't create a variable. Okay. What time does this class end? 4:20? 4:25?
420.
This is probably painful. You're thinking, my God, a semester of this? I can't take it. Isn't that frightening? Yeah.
Where do we use this? Like,
In life, when you go shopping. Yeah. The problem is that this stuff will not come in handy in your daily affairs. However, if you're programming and you're doing C, C++, you will come across this pointer stuff all the time. I want to go and tell you, I was, a programmer for some time myself, and I, would go to school just like you guys, okay, and so I finished my degree, and so they gave me a job, doing C++ stuff. And there were other programmers. I think there were like 80 other programmers in the outfit that I was working at. And there were like 3 of these programmers who were really experts. The rest of them, they were just mediocre. And so they would give us all these programs to go and write. And there was a lot of this asterisk and ampersand. And out of all these 80 programmers, it's only those 3 people that knew what was going on. When I was writing code, I would say, okay, so I guess maybe let me go and just try 1 asterisk. They wouldn't compile. Well, let me try 2. Okay. And then I would put in these asterisks and it would work. Okay, and then you say, this code is working. Now the company didn't have enough money to go and hire these people to go and test out the programs. So we write the program, okay, and then we did our really just minor testing, and then we say, it's ready for production. It goes out there, the program crashes. And we say, okay, so there's a pointer problem. Well, let me go ahead and put an ampersand. Guess what? The company went bankrupt. Because of people like me. So that's where it comes in.
so you're telling me to not be like you?
Well, yeah, so I'm saying, that if you're going to be programming in C++, then you need to know what this pointer stuff is. And as we go further into this class, we'll be using this stuff quite a bit. So you'll need to know this. And the best way to go and make sure that you know it is to make sure that you draw these boxes and you know exactly where you are in the boxes. Anyone else? Nothing. So, yeah.
So, it's about the book, so you said that you still recommend that we read, chapters of the book and, cover it
I don't know what that book is. I mean, I haven't looked inside the book too much. And I think what's inside the book it corresponds to, the stuff that we say, but it doesn't correspond to the sequence that I'm covering. And, the stuff that I had, some of it is in this book, some of it is from some other book, So basically, what I encourage you to do is when you're having a problem with a concept that I'm going over, is for you to just go ahead and take a look at some YouTube channel, okay? Some YouTube video, and then find out that somebody else has the same values. So if this dereferencing stuff is that's confusing you, just start looking up YouTube videos and see what that does for you. And I don't have any recommendations as to which one is good. Just look it up. The one with the most views, those are probably good. Yes, somebody else had a question.
I guess I just never really understood why you do a pointer to a pointer. You asked me why would you not point? Because,
Why would you have 2 pointers?
yeah, why would you do two jumps instead of just setting another variable as a pointer to the initial value that you want?
Well, of course, when you're dealing with pointers, it's very possible that you could actually go ahead and, let's go ahead and let me give you the easy answer. When I was drawing a single dimensional array, I'll just go ahead and give you the overall view. We had this thing, like this link, and then there were like these 3 items that we were storing. Yes? Okay. Now, what happens if it's a 2-dimensional array? Guess what happens? Every single time you have one of these columns, that is another jump. So you go from here to here. You go from here to here. When you're dealing with a 3-dimensional array, what is that? That's yet another jump. And yet that's another asterisk. So 1 asterisk here, another asterisk there, another asterisk there. So really embedded in just the entirety of C programming is a bunch of jumps. Yeah.
Thank you.
Yeah. Okay, anything else? Nothing. So do you think we've had enough for one day? All right. Do I have any homework assignments? You can't have a homework assignment on day 1. That's crazy. So I think we're saying we're done. All right.